Subcircuits are like a function in any high-level programming language. This means they are the code blocks which is defined outside the main program and they later called into the main program. So you can see the syntax. This is a subcircuit that is outside the main circuit and later introduced here. This is a subcircuit for a 4 input AND gate and it is defined with a command character. Later when it is called there is no command character. The subcircuits are mainly classified into two types, that is predefined subcircuits that are already defined. You can find them a comprehensive list here and later they are introduced here as the input and output nodes, and then there are user defined subcircuits. In this program I have shown in user defined subcircuit. So how it is executed: for a 4 input AND gate, these are the 4 inputs and this is the output. So there are 3 AND gates. The AND 2 are the 2 input AND gates. 2 input AND gates are used to combine to perform the work of a 4 input AND gate. The circuit can be like this. So this is the first and second node and this is the third and fourth node and this is the seventh node here. The input nodes 1 2 3 4 and this is the output node. Later it was called here and then the voltages were fixed and we performed a truth table analysis where the input nodes are taken 10 11 12 13 and 14 is the output node. So as you can see, there has to be the same number of arguments in the subcircuit when it is called as when it is defined. There are 5 comments and there are 5 arguments, and here you can see there are 5 arguments. They need not be same, and as you can see they are not the same here. Then I have printed the node voltages of the subcircuit 10 11 12 13 14. So let's see how it performs. So let us open the PowerShell as administrator and here I will type the circuit zebra subcircuit.txt, enter, and here it is the truth table. This is the 10th node, 11th node, 12th node, 13th node and 14th node, and here you can see the truth table and the simulation ended. So this is all for the user defined subcircuit. Now here is another subcircuit, that is predefined subcircuit. Here I have used the 4:1 multiplexer subcircuit and fixed the voltages around the nodes and ran a truth table analysis on the nodes 1 2 3 4 5 6. So what are these nodes? The let me see the how it is defined. So this is how a 4:1 mask is defined. The first node is the S1, that means the most significant bit. So it is 1 is the most significant bit and 2 is the least significant bit in the select lines, and here are the input lines I0 I1 I2 I3 3 4 5 6. These are the select lines and 7 is the output line. So I have fixed some voltages in the select and input lines and then performed a truth table analysis, so it was not really needed. Let me run the program. Zebra, the file name is subcircuit_t. So this is the simulation data, and if we start the simulation, then these are the nodes 1 2 3 4 5 6 7. Depending upon the select lines, the input lines are selected. and let me just take a random data 1 0. So the third input will be selected 0 and we will get the output as 0. So it is working, I think. This is all for this video.